Good morning to all present here. Let us see the concept generations and the embodiment in the smart manufacturing process. Then about the impact of additive manufacturing. What is meant by additive manufacturing? Here, the additive manufacturing, which represents the shift, a paradigm shift in the fabrications, building parts, and the layer by layer, which creates the 3D models, eliminating traditional tooling constraints where which gives the industry impact on aerospace, medical, automotive, and all the consumer products. So this gives the smart manufacturing in all the mechanical industries. What is meant by the empathy of these AM, where understanding the manufacturing challenge, the speed constraints, and then uh, customer customization gap, and then cost barriers and the design limitations. These are all some of the speed empathy part of the additive manufacturing. The traditional manufacturing imposes weeks or months of lead time for prototype, and then severally, which gives limitations, iteration velocity, and time to market. Cost barriers, high tooling expenses, which made the low volume production economically unfeasible, which gives the compromises in design explorations, where this cost will give that, where compromises on the design. And the design limitations, which gives the more complex internal geometries, lattice structures, or organic shapes efficiently. And then customizations gap, where this mass productions of these will give it the personalizations, creating barriers for specialized applications and individual needs. This is all about the empathy of this. And then articulating the core problems, which gives that time to market pressure, and then material waste reduction, and customization demand, then tooling cost eliminations, complex geometric capability, where what is meant by time to market pressure is accelerating the product development cycles to maintain the competitive advantage. This is all they making a mm, product development cycles, minimizing the environmental impact on cost from subtracting manufacturing waste. Environmental, why we go for the smart manufacturing or additive manufacturing, which will give the material waste reductions, where we protect the environment and also will give the cost impact on the material waste. Then customization demand, where which will give the market expectations, where the personal requirement. And then tooling cost estimations, removing economic barriers to design iterations of low volume production. So this will give the tool the number of usage of tools in addition. So this will give tool cost eliminations. And then complex geometric capability, enable the lightweight structures, internal features, and biomimetic designs. This is about the different stage of the AM. And then ideate a part of this AM is the layer by layer innovations called breakthrough concept. Here, revolutionary insight builds additively rather than the subtract to create a directing digital to physical workflow that eliminates traditional tooling things, and then which gives the fundamental shift of possibilities for materials, geometrics, and then production economics previously unimaginable. These are all some of the material removal things, where VAT photopolymerizations, powder bed fusions, material extrusions, and advanced process. This is about the mind mapping of the system development ecosystem of the additive manufacturing or the smart manufacturing, where the first is the design stages. Here we go with the empathy, and then define, and then ideate, and then prototype and test. Where this is about the stages of design thinking, where which will provide for product making of the through smart manufacturing. And then needs, where the faster prototyping is required, where today's the more number of volume of productions is need in all the places. So the fast prototyping, the complexity, customizations, and minimizing the waste, so that will improve the volume of productions and also the quality of the product. And then technology, where CAD modeling we can use, and then digitalizations, laser techniques, and then EDM techniques, and